Hello friends and welcome for our next problem by slope deflection method. Here is one more continuous beam. This is somewhat different from previous numerical. We can see here on DE there is an overhang of 2 meters. I have also shown how this overhang portion will be going to bend. Usually what happens when it is a simply supported beam bends in this fashion, correct? And there is tension on side below the neutral axis and compression above the neutral axis. Here it is exactly opposite of this. This part is exactly opposite of this bending. So here it will be tension and here it will be compression. So there will be a moment of minus 80 kilonewton, 14 to 2 on support D, which is a free moment. Okay, this is a free moment and that will be treated as final moment. Okay, so let us start with our usual procedure. Our first step is kinematic indeterminacy. So that kinematic indeterminacy is again 2. So which are those two unknown rotations? Those are theta B and theta D. Some more input is given for us and that input is 2I, 1I. It means moment of inertia of this AB beam is 2I. For rest of the beam BDE it is 1I. So there is change in depth. Okay. Now second step, as usual, fixed end moments. So let us calculate one by one fixed end moments. So MFAB is minus WL square by 12. Straightforward. So minus 20 into 6 square by 12. How much? 36 by 12 is 3. So minus 60 kilonewton meter. Okay. Then MFBE, it will be plus. I will write now directly. Plus 60. Then there is no BC, there is BD. So MFBD. MFBD central point load. So minus WL by 8. So how much is that? Minus 60 into 4 by 8. So how much will be this? Minus 30 kilonewton meter. MFDB, it will be plus 30. Okay. And as discussed earlier, MDE we are going to get final moment 14 to 2 with minus sign. Minus 80 kilonewton meter. Okay. Now come to our next step, number 3. What is our step? Slope deflection equations. So let us do these equations one by one. So MAB, what is MAB? 2EI by L into bracket 2 theta A plus theta B minus 3 delta by L minus MFAB. Okay. So 2E into 2I. Carefully substitute the value because I value for span AB 2I. Theta is 0, so there is theta B. Delta, There is no delta because there is no sinking given. If it is not given, we will assume that it is 0. So minus MFEB is minus 60. So how much is this? 2 into 2, 4, 4 by 6. 4 by 6 is 2 by 3, correct? 4 by 6 is 2 by 3, so 0.67. 0.67 EI theta B minus 60. MAB is over. Then come to MBA. Similar equation, 2 EI by L into bracket theta A plus 2 theta B minus 3 delta by L plus MF BA. So again 2E into 2I upon 6 into bracket 2 theta B. Theta is 0 again, delta is 0. So MFBA is plus 60, correct? So how much will be this? 8 by 6. 8 by 6 is 1.33. So 1.33 EI theta B plus 60. Okay. Now come to MBC. What is MBC? 2 EI by L into bracket 2 theta B plus theta C minus 3 delta by L plus MFBC. Substitute. Here I value is 1I. Okay. So 2 EI by L for sorry, this is BD, not BC. Here is also BD. So MFBD, MBD. L for BD span is 4 into bracket. This is not C, this is theta D. So 2 theta B plus theta D, no sinking, MFBD minus 30. Simplify this. So MBD is equal to 2 into 2, 4. 4 by 4 is 1. So EI theta B plus 0.5 EI theta D minus 30. Okay. Now MDB. MDB is 2 EI by L into bracket theta B plus 2 theta D minus 3 delta by L plus MF dB. Substitute 2 EI by 4 into bracket theta B plus 2 theta D MF dB, how much? Plus 30. So this is equal to 2 by 4 is 0.5, so 0.5 EI theta B plus 4 by 4 is 1 EI theta D plus 30. And final MDE we have already written minus 80 kilonewton meter. Okay. So this was step number 3. Now come to step number 4. Equilibrium equations. What are equilibrium equations? One is on joint B. So at joint B, we have MBA plus MBD is equal to 0. So what is MBA? 1.33 EI theta B plus 60. In this we have to add MBD. So 1.33 EI theta B plus 1 EI theta B. This is 2.33 EI theta B. Then theta d, it is 0.5 EI theta d. Plus 60 minus 30 is plus 30. Bring it on right hand side, it will become minus 30. So this is equation 1. Okay. Now second condition is at joint D. What is at joint D? MdB plus MdE, it is equal to 0. Okay. So what is MdB? 0.5 EI theta B plus EI theta D plus 30 minus 80 is minus 50. You bring this on right hand side, it will be plus 50. So this is equation 2. So solve equations 1 and 2 simultaneously. You will get EI theta B as minus 26.44 and EI theta D as 63.22. Okay. So now we will go for final moments, step number 5. Final moments. So we have these final moments. I will just show these final moments here in the diagram. MAB is minus 77.71, MBA 24.83, this is 80. That's it. Now we will go for finding out reactions. Step number 6. So sixth step is reactions. So finding out these reactions correctly is an important task, because this is going to give us shear force diagram and bending moment diagram. So let us first of all draw free body diagram for span AB. Show these reactions, external loading, so this is 20 kilonewton per meter UDL, this is 6 meter span, this is RA, this we shall assume as RB1. We'll find first of all RB1 using conditions of equilibrium. So summation of moment about A is equal to 0 minus RB1 into 6 plus 24.83 plus 20 into 6 square by 2 minus 77.71. It is equal to 0. So let us find RB1 first. So 24.83 plus 20 by 2 is 10 into 6 square minus 77.71. This total is divided by 6. So it is 51.19 kilonewton. 51.19 kilonewton. Now we will apply another condition of equilibrium. Summation Fy is equal to 0. So Ra plus 51.19, it is equal to 120. So what is Ra? 120 minus 51.19. So that is 68.81 kilonewton. Correct? Now come to span BD. I will show here. So these fixed end moments, final moments 24.83 and this is plus 80. This is RB2 we shall assume and this is RD. This is 2 meter each. Correct? So summation of moment about B. So I shall assume this is RD1. So minus RD1 into 4 plus 80 plus 60 into 2 minus 24.83. This is equal to 0. This is going to give us RD1. So 80 plus 60 into 2 minus 24.83. Correct? This total is divided by 4. So 43.79. We are getting the answer as 43.79. Again summation Fy is equal to 0. So RB2 plus 43.79. This is equal to 60. So RB2 will be how much? 60 minus 43.79. 16.21. Okay, both calculated answers for RB values are positive, hence they are upward. So what will be net RB? RB1 plus RB2. How much is RB1? 51.19 plus 16.21. So 67.4 is net RB value. Okay, now come to last part, DE. So this is 40 kilonewton. This is 80. This is RD2. RD2 we will get directly using summation Fy. So what is RD2? 40. So what will be net RD? RD1 plus RD2. How much is RD1? 43.79 plus 40. So it is 83.79. Okay. So let us show these reactions here. $68.81. kilonewton. Net RB. What is net RB? 67.4 kilonewton. Net RD 83.79. Okay. Now we will draw shear force diagram. So let us draw now shear force diagram. 68.81 is the ordinate here. Then minus 20 into 6. So 68.81 minus 120. So 51.19 with minus sign. So somewhere here, kilonewton. And this adds 67.4. So minus 51.9 plus 67.4. It will give us 16.21 kilonewton. It will be same up to 60 kilonewton point load. So plus 16.21 minus 60. So it will be 43.79 kilonewton. So it will be same again up to support D. So minus 43.79 plus 80. It will be 36 point, not 80, it is 83.79. So minus 43.79 plus 83.79, we are going to get plus 40. So here is 40 over. Our shear force diagram is over. So which are the locations of zero shear force? One is here. I will mark them with black color. These are the locations where bending moment will be maximum. So this is A, B, C, D, E. I shall say this as F and then G. First of all, we need this location of zero shear force. We shall assume X. So how much is this? 6 minus X. So when X is the ordinate, we have 68.81 as the value. When 6 minus X is there, we have value 51.19. Take the cross multiplication. 51.19x is equal to 68.81 into 6 minus x. So it is 412.86 minus 68.81x. So how much is x? Find out. So it is 3.44 meter. So find out now bending moment at point F, which is x is equal to 3.44. So 68.81 into 3.44, because section is here at point F. You assume now everything in the loading diagram on left hand side of this section. So 68.81 into 3.44 minus 77.71 minus 20 into 3.44 square by 2. Calculate this value. There is nothing apart from these three. This is one, this is second, third. Yes. So 68.81 into 3.44 minus 77.71 minus 20 by 2 is 10 into 3.44 square. So it is 40.66 kilonewton meter. Then bending moment at point G. So bending moment at G is, again you consider this section, and at this section you are considering everything on right hand side. So 40 into 4. So minus 40 into 4, because it is clockwise on right hand side of the section. Then this 80 is going to get nullified, plus 80 minus 80. And then plus 83.79 into 2. So 7.58. Answer is 7.58 kilonewton meter. Bending moment on G. I will redraw this line. So now show the ordinates one by one. Bending moment on A minus 77.71. Bending moment on F plus 40.66. Bending moment on B 24.83. Bending moment on C. Okay, so this is not G but C. Okay, we need not give this any new number. So bending moment on C is 7.58. Bending moment on D minus 80. Okay, here it's 0. So join these ordinates. A to B UDL. So something like this. Then everything is point load, so straight lines, no curve. That's it. This is minus, this is plus, minus, plus, again minus. So this is our BMD in black color. BMD on tension side. And this is shear force diagram in red color. So friends, if still you feel you are not understanding, watch the video completely and then write in the comment sections your difficulties. I'll try to answer them. Thank you.